Hi everyone, welcome to ZabiCore channel. So in this video we'll discuss Snowflake architecture. By the end of this video you will understand how Snowflake works. Basically in Snowflake we have three layers: storage layer, compute layer and the cloud service layer. So in storage layer we can store the data, like in any one of the cloud provider we can store the data. So basically Snowflake uses three cloud providers like AWS, Azure or GCP. So we can store our data in any one of the cloud provider. So while creating Snowflake account, it will ask like which cloud provider you want to use to store your data. Okay, so I'll create separate video how we can create the Snowflake account. So right now just focus on the Snowflake architecture. So storage means we can store our data in any one of the cloud provider in simple terms. And compute layer, so we are storing data in any one of the cloud provider, right? So how we can read the data? So whenever you write the query, so that query will be executed in the virtual warehouse and data will be read from the storage. So cloud service layer, so in the cloud service layer, so whenever you write any complex queries, so it will optimize that complex query and it will also share that metadata where your data is stored, right? So that all information will be shared to virtual warehouse. So virtual warehouse can read the data from the storage and it will display the results. So storage layer, so as we already know, storage layer we can use to store the data, but here how our data will be stored? So our data stored in compressed columnar format. So whenever you store your data in the Snowflake, so it will compress, then it will store your data in the cloud providers, correct? So like first we'll discuss the columnar. So whenever you store the data in the Snowflake, it will stored in a columnar format. So these are the main topics we have in the storage layer. So columnar storage, compression, micro-partition, metadata and the cloud storage. So let's discuss like what is the columnar, how data will be stored in the Snowflake. So columnar storage, so whenever you want to analyze extremely large amount of data, columnar storage is the best practice. We can store our data in the columnar format. So whenever you are reading the data or whenever you want to analyze large amount of data, the columnar format is the best format to analyze the data. Okay, so how our data will be stored? So here we have one example, some student details, std1, std2. So whenever you try to store this data in the Snowflake, it will store in a columnar format like name, id, email and marks. So whenever you retrieve only marks, like select marks from the table, it will only retrieve the marks data. So it will not query the another column data. Suppose when you query only the email data, so it will only retrieve the email. Okay, it will not check the name or id and marks columns. So these are the main cloud providers. So whenever you store any table, so your table information will be stored in the any one of these cloud provider, but directly we cannot check file in that cloud providers. So everything will be handled by the Snowflake. So here we don't have permission to see that file stored in the any cloud provider. So just we can, so that all information will be stored in the cloud service layer. So that information will be passed through the compute layer. So columnar storage means like whenever you want to analyze the large amount of data, it's better to store your data in the columnar storage. Row based storage, so whenever you store your data in the table like databases, so your records will be stored like this, like name, id, email or marks. So here whenever you write select name from table, it will read all the values, it will read all the record, then it will display only whatever information you want. Okay, so basically this row based storage will use like whenever you are updating frequently, whenever you are updating your records frequently, so at that time we can use the row based storage. Okay, so these are the databases where our data will be stored in the row based storage like Oracle database, MySQL and PostgreSQL. So document storage is also one of the most popular format to store our data. So we can store here semi structured data. So mostly this document storage will apply in the real-time applications like Instagram, Facebook, LinkedIn. All these real-time applications will use the document storage. So here one example you can see. So here we have one student like ID, name, course, skills, address, city and state. Some students may have another skills, like some students may have multiple addresses, correct? So here we have to change the schema dynamically. It is here in document database we have flexible schema, there is no fixed schema. But in the Oracle database you can see, suppose if the table is contains name and email id, we have to enter only name and email id. But in document database we can store, we can change the schema. Like suppose we can take example, here we have two students. One student has the only name and skill, another student has the name and experience. So here schemas are different. So here flexible schema we can achieve in the document storage. So here are the some of the applications we can use this document storage, like e-commerce applications, social media or chart applications, or content management systems. So this type of applications if you want to build, you can directly select the this document storage. Before storing data in the columnar, first it will compress the data. So whenever you compress the data, like imagine we have 5 GB data. So whenever you compress, so it will become 1 GB data. So Snowflake here use some of the compression algorithms to compress your data, and it will store that compressed data in the any one of the cloud provider. So why we have to use this compression? See, compression, it will save the storage cost. It will also reduce the input and output readability, and improve the query performance, correct? So these are the type of compressions we have. But in Snowflake we don't know which compression it will use internally, but these are the compression algorithms we have. But in Snowflake it will use some advanced compression algorithms to compress their data. So here we can take one example, run length encoding. Suppose we have India 4 times. So how we can compress this algorithm RLE? So it will just compress like India into 4. So India multiply by 4, it will become India 4 times, correct? This is the one type of compression algorithm. Next we have dictionary encoding compression algorithm. So here we have some country names. So here India is repeated 2 times, and we are assigning some IDs, like India means 1, UK means 2, and USA means 3, correct? So how this data will be stored? It will store like this, like 1 2 3 1, correct? So this is the, dictionary encoding compression algorithm. Next we have delta encode. So delta encoding, so imagine we have like this numbers, like 100 101, like this we have numbers. So how we can compress this? Instead of storing exact values, so here we can observe one pattern. So every value is increment by 1. So we can compress using this delta encoding, and we can store value like this, like 100 plus 1 plus 1 plus 1, like that we can compress our data instead of storing as it is, correct? So we discuss columnar storage, compression, multi partition. So your data will not store in a single file. So your data divided into multiple partitions. It will not store in a single partition, correct? So Snowflake divides your data into multiple partitions, then it will store all your partition into any one of the cloud provider. So imagine we have one table and we have only one partition. So whenever you query, so it will check that partition and it will retrieve the data. But all these partitions are immutable partitions, we cannot change. But how we can update the value, like how we can insert the value in the table? Whenever you want to insert something or you want to delete something, how these partitions will change? So these partitions are immutable partitions. So imagine we have one table here and one partition. Whenever you update something or insert something, it will create new partition. So your table will refer the new partition and will not refer the old micro partition. It will not refer this P1. Now it will refer the P2 partition. Why? Because we updated something, correct? So what happened to this P1 partition? So here Snowflake use the time travel concept. So whenever you want to go back and see what is the data, so it will refer to this P1 partition, correct? So I'll do one separate video how this time travel works in Snowflake. I hope you understand, right? Like this columnar storage, compression and micro partition. So next we have compute layer. In a simple terms we can say, so this compute layer we can use the virtual warehouses to run our queries. In simple terms, our data will be stored in the storage layer. So using this compute layer, we can read the data and we can modify the data. So we can observe storage independently. Why this separation is powerful? Like you can observe in Snowflake architecture, each layer is separated by each other. So it is not depend on any other layer. We can also increase the storage. Suppose if you want to increase the compute power, we can also increase the compute power. So it is not depend, it is decoupled architecture. Okay. So here we have some of the warehouses sizes here, like X small, small, medium, large, X. So depends on your requirement. We have to select your warehouse size, correct? So X small means it will credit 1 credit for every hour. So here we need to purchase some credits if you want to use the Snowflake platform. So whenever you create the Snowflake account, it will give 400 credits. So whenever that credits are over, you need to pay some amount, then they will give some credits to your account. So here if you are using X small warehouse, so it will credit 1 credit for every hour. Okay. Next we have scale up or scale out. So scale up is nothing but increasing the warehouse size. So here we can see X small to we can increase to small or medium, large, X large. So that is the scale up. What is scale out then? So we can add multiple clusters. Suppose whenever you have multiple users, so your warehouse can run simple queries, it will take more time when you have more users. So what we can do here, we can add multiple clusters, multiple warehouses we can add with the same capacity. Like in the simple terms, I can say scale up means we can increase the size. Scale out means we can add, like suppose if I am using X small server warehouse, we can add multiple X small warehouses to serve the multiple customers. So here Snowflake provides pay as you use. Whenever you use the servers, you have to pay only for that resources. If your server is not using, so Snowflake automatically put that server into suspend mode. So whenever you run the query, it will automatically run. Okay. Next we have cloud service layer. So in cloud service layer, so it will manage everything, like suppose authentication, authorization, metadata, query parsing, query optimization, everything will be handled by the cloud service layer. So whenever you log in into your Snowflake account, just the cloud service layer, it will check whether you have the correct username or password. Suppose if you are trying if you are logging successfully, so it will also check whether, like when you write the query, it will check whether you have permission or not that particular table to view that data. So all this information we can handle in the cloud service layer. So this is the flow. So whenever you write the query, so it will get the some metadata information, micro partition information, it will optimize your query. So all that will be done by the cloud service layer. So then the next stage we have compute layer. So in the compute layer, it will use the virtual warehouse server to retrieve the data. Next, it will process the query, then we can see the result. So this is the complete flow, how it is execute whenever you write any query. So this is the flow from top to bottom. It will execute from cloud layer, compute layer and storage layer. So let's discuss what are all the topics we covered in this video, Snowflake architecture. So we have 3 layers in Snowflake: cloud service layer, storage layer and the compute layer. Storage layer means we can store our data in any one of the cloud provider. In a simple terms, how the data is stored and the columnar storage, and it will compress the data. Whenever you have extremely large amount of data, it will divide into partitions. Okay, that is the storage layer. Next we have compute layer. So it will execute the your queries, uses virtual warehouses, read data from the storage layer. So next we have cloud service layer. So in cloud service layer, so all your metadata optimization, everything will be happened in the cloud service layer. So I hope you understand this Snowflake architecture. So in the next video, we'll discuss with some other topic. If you found this video helpful, subscribe to ZabiCore channel